So for question 6 from the practice exam, we've got this diazine molecule, so N2H2. So we want to draw the Lewis structure for that so we can figure out how many valence electrons we have, the central atom. So I've got 2 nitrogens, right? Nitrogen is going to have 5 valence electrons each. So that's a total of 10 valence electrons I need to assign from nitrogen. 2 hydrogens, 1 electron each for hydrogen. So there's 2 total electrons from hydrogen. So 12 total between nitrogen and hydrogen. The next step, we want to make the Lewis structure for this. So I would start with nitrogen and nitrogen. We got to figure out how to assign these 12 electrons. And we've got to connect it to 1 hydrogen each. And we've got to fill the octets of both of those. So there's 2 electrons, there's 3, 4 electrons, 5, 6, 7, 8 electrons. So forming that double bond, we've assigned 8 electrons in total. So I've got 4 electrons left. If we look at that Lewis structure, right, we have not filled the octet for nitrogen. Right now, nitrogen just has 6 electrons in its outer shell. So to fill the octet, we can put the last 4 electrons as a lone pair on each of the nitrogens. So that's kind of the best Lewis structure we can come up with because we filled the octet for nitrogen. For both of those nitrogens, we filled the octet. If we also, so let's check number 1, right? We want to make sure we haven't violated the octet rule. We haven't violated the octet rule. Check number 2 would be formal charge. So nitrogen is group 5. And to figure out how many assigned electrons we have on nitrogen, I'm going to count 1 electron for each bond. So 1, 2, 3. And then I count all lone pair electrons. So the other good thing about this structure, right, is that nitrogen is neutral. We don't want to violate the octet rule, and we don't want to carry charge unless we have to carry charge. So those are the checks you should always do when drawing a Lewis structure for the first time. So there's our Lewis structure, right? Question A, right? We've already answered question A. Total number of valence electrons. We've got 12 valence electrons we have to assign, right? And you don't need to include the E for electrons. It would just be 12. The central atom, well, nitrogen is our central atom. In that Lewis structure, there are a total of how many lone pairs of electrons on the central atom, right? And I have a total, so I would kind of consider both of those nitrogens as central atoms. So I would say I've got 1 pair, I've got 2 pairs of lone pair electrons on our central atoms for nitrogen. And there are how many single bonds, double bonds, and triple bonds in this molecule, right? So how many single bonds? We've got 2 single bonds, right? The nitrogen, hydrogen, those are my single bonds. And then for the double bonds, I'm going to have 1 double bond, right? That nitrogen double bond. And then obviously, right, we're going to have 0 triple bonds. We do not have any triple bonds in this Lewis structure. Be careful because here they're asking for single and double bonds. If they were asking for sigma bonds, the answer would be 3. We would have 3 sigma bonds in this structure because this would be a sigma bond, this is a sigma bond, and then in this double bond, we would have 1 sigma and 1 pi bond. But here it's just asking for single bonds versus double bonds.
Just using this question as an example, but I have trouble recognizing how many electron domains there is. How many would this question have?
Yeah, and that's one of the things I was thinking when I drew this out. So I kind of drew it, not in the best way of thinking of the electron domains. So if we want to think about it in terms of our electron domains, we really should draw it, right? like this because this should fit into the trigonal planar electron domain geometry because we have 1, 2, 3 domains around the central nitrogen, right? I've got 1, 2, and 3 domains. Sorry, the red doesn't show up too well here. But this is a domain, the lone pair of electrons is a domain, and that double bond is a domain as well. So we've got 3 total domains because domains are regions in space. So this is one region in space. This is also a region in space, the lone pair of electrons. And then even though there are 2 bonds in our double bond, it still is only defining one region in space. So it still only counts as one domain. So electron domain geometry would be our trigonal planar, and then the molecular geometry would be bent because of that, because I've got 2 bonding and 1 non-bonding domain. Yeah.
So you wouldn't count like the other lone pair and the other bond?
Well, we would set, so the question is, why wouldn't we look at the other nitrogen as well? When we're setting our geometry, we would just look at the central atom. So we would look at this nitrogen and we would see this nitrogen has 3 domains. So with respect to this nitrogen, we're trigonal planar, approximately 120 degrees. And then we would come down here and we would look at this nitrogen separately to see it's also trigonal planar. When we're counting this double bond as a domain, right, that includes basically what that double bond is connected to. It includes that nitrogen as well. So we don't have to look at those on top of this nitrogen, right? This double bond is including what's connected to the other half of that double bond.
And also, just for like making the Lewis structure, how this is kind of like a different sort of how would you kind of that nitrogen, other nitrogen, and stuff like that?
So one of the things that we all know is that hydrogen can only have 1 bond. So hydrogen is not going to be in the middle because hydrogen can only have 1 bond. And then that's why I suggested to kind of work through those steps of, did I violate the octet rule for anything? What are my formal charges? Because we could certainly make a Lewis structure where, let's say, we just did a nitrogen single bond. So if I do that, there's 6 electrons. So I've got 6 electrons, right? I've got 12 total. I assigned 6. I've got 6 electrons left. If we started with this, we kind of run into a problem because I've got 6 electrons left. All right, I'm going to put 2 here. I've got 4 more electrons left. All right, I'll put 2 here. I've got 2 electrons left. I have a problem because I've got 6 electrons. I've got 6 electrons on that nitrogen. I've got 6 electrons on this nitrogen, and I only have 2 left to assign. So if I do another lone pair, okay, great. I filled the octet for this nitrogen, but I'm violating the octet rule for this nitrogen. We don't want to do that. And this would also create a formal charge on both of these nitrogens. So it's going to take a little bit of practice of working back and forth. And yeah, certainly if you want to start with a single bond for all 3 of these to kind of realize, all right, I have no way of making a full octet for everything here with a single bond. We could do the same thing if we made a triple bond to kind of realize that, and I'll get to your question in a minute. All right, if we did a triple bond, I'd have to get rid of 2 pairs of those electrons. All right, there's my triple bond. Now I have a problem on the other end, right? Now I have a problem in that I've violated the octet rule for nitrogen on the high side, and I can't do that either. So it will take a little bit of practice in making these Lewis structures, but the question you always want to be asking is, did I violate the octet rule? Yes or no? And then what are my formal charges? And that's going to help you figure out, am I on the wrong track somewhere with my Lewis structures?
So hydrogen you said has 1 bond. Is there any other elements that
also have like an exception to the octet rule?
Yeah, so hydrogen will only ever have one bond. Will typically, right, boron was the other one we talked about. Boron will only typically have 6 electrons in its outer shell, so 3 total bonds. A lot of the Lewis structures we saw, like the halogens, people make this mistake all the time. We did like sulfur tetrafluoride, right? Unless the halogens are the central atom, halogens will only ever form one bond as well. It still has a full, all these fluorines still have a full octet, but typically our halogens, when they're going to be a peripheral atom, they will only form a single bond as well.
So this would be like an exception. When you need one bond, do you need like with the other elements?
So these halogens will only ever form a single bond unless they're the central atom, right? We saw like chlorine, we saw chlorine trifluoride, right? In that case, chlorine does form more than one bond, but it's the central atom in that case. So hydrogen only ever wants to form one bond. When the halogens are a peripheral atom out here, they will also only ever want to form one bond because they have 7 valence electrons. They only need to share one more electron to get 8 full, 8 electrons in their octet.
When a halogen becomes a central atom, does it violate like the first like quantum octet to get to the next level?
Yeah, and we'll only see this for things like chlorine, bromine, and iodine, because chlorine, bromine, and iodine, right, they have access to their d orbital. So that's how they can take more than one bond, because they're using their d orbital. They're hybridizing with their d orbital to account for these 5 domains in the case of the chlorine trifluoride. So yeah, we're not going to see fluorine ever be the central atom, but chlorine, bromine, iodine could all be the central atom. And when they do that, they're doing that because they're not using the 1p orbital anymore. They're using d orbitals as well.